Today we have a following question to solve. Let's first read it and try to understand, and then we will find the solution of this question. The question is the equation of the circle whose center is at the point O prime is x squared plus 32x plus y squared minus 24y is equal to 0. The coordinates of point A are negative 34.794 meters, and y coordinate is 18.840 meters, and those of point B are negative 7.548 meters and 30.126 meters. The tangents to the circle line AC at A and the line BC at B intersect at point C. Find the coordinates of point C to a precision of 1 millimeter. So if we will solve this question just within meters, then we should have the solution up to 3 decimal places because millimeter is 1,000th part of a meter. Now let's try to understand this question. And here we also have the diagram. What we do have, we have circle, and the equation of this circle is given. And then we have also given the coordinates of a point A and point B. At these 2 points, what we do have, we have tangents, and these tangents are crossing each other at point C. So let me give you first a simple understanding about this question, which will help you to solve this question. So first of all, that we know the equation of this circle, and then we actually need to find the coordinates of the C that are X and Y. And if you look carefully, that this C is actually a common point, the point where both of these tangents, AC and BC, are intersecting. So it means that this C is a simultaneous point for the line AC and BC. And this actually tells us that if we will solve the equations of line AC and the line BC simultaneously, we can find the coordinates of this point C, which is a common point. Now, the next question is that how can we find the equations of BC and AC? We can see that these are the straight lines. So then the equation of the straight line is y minus y1 is equal to m into x minus x1. What m here is, so m is our gradient. So this m is gradient of the line. That is gradient of the line. And then what are x1 and y1? So these are the coordinates of a point, and that point must be at this line. So for an example, if we want to find the equation of line AC, then what we must have at least the coordinates of one of the points at this line. We know that we have the coordinates of a point A that are minus 34.794, and y coordinate is 18.840, and these are given in meters. So we have the values of y1 and x1. What we do not have the value of the gradient of this line AC. Now, how can we find the gradient of the line AC? This is very simple. If we know 2 points on the line, then we can find the gradient of the line. But we have only the information of one single point. What we can see that actually this is the tangent of this circle, And then the radial vector, as shown in this diagram, which is O prime A, it is the radial vector. And according to the theorems of the circle, that the radial vector is always perpendicular to the tangent of the circle at that point. So it means that if we know the gradient of this radial vector O prime A, we can find the gradient of the tangent because these both lines are perpendicular to each other. If that are perpendicular to each other, then we can actually find the gradient of one and apply the negative reciprocal of two perpendicular lines for the gradients. Okay, so this means that if we will also get the information of the gradient of these tangents, then we can find the equations of the lines and we will solve that equations simultaneously to find the coordinates of this common point where they are intersecting C. So for this, let's first find the gradient of the line O prime A and O prime B. But we know the coordinates of the A. We must also know the coordinates of the point O prime, which is the center. So then we will have 2 points of this radial line and we can find the gradient that will be negative reciprocal gradient of the tangents. Okay, now we have given the equation of the circle. From the equation of the circle, we can very easily find the coordinates of the center. How can we do that? For example, here, the equation of the circle is x square plus 32x plus y square negative 24y is equal to 0. So this is the equation of the circle. If we write it in its journal form, then we can find the coordinates of the center of the circle and also the length of the radial vector. How can we do this? Let's do this. The general equation of a circle is a following that we have x minus a square plus y minus b square is equal to r square. So here this a and B are the coordinates of the center of the circle, and this R is actually the length of the radius of the radial vector, meaning that this is actually the length of the radius of the circle. Now, this equation of the circle, we can very easily write it in the form of a general circle equation. How that we convert actually these first two terms into a complete square in the form of x minus a and the last two terms as y minus b square. So the rule is that we have here x square, there is no coefficient, and we have the x term, then the square will be, as we actually learned it in a quadratic equations solutions, that this we can write it as x plus half of 32, which is 16. So this is x plus 16 square. But there must be a compensational term, which is minus 16 square. Now, the next two terms where we have y square minus 24y, so this can be written as y minus 12, its square, then minus 12 square, it is equal to 0. Now we can see that our this equation is turning in the general form of the circle. So x plus 16 square plus y minus 12 square, and we have here 16 square and 12 square that are negative. What on the other side of the equation, they will be positive. So square of 16 is 256 plus square of 12 is 144. So this sum is equal to 400. So now let's compare our this equation, and let's call it that this is our equation number one, and let's compare it with the general equation of the circle. So I give the name C for circle to this equation. Then we can see that we have x minus a square. A is the x coordinate of the center of the circle. And we have given the name to the center of our circle O prime. Then coordinates of O prime are that negative 16, negative 16. So here we must have a y minus b, and we have a y minus 12. So the b, meaning the y coordinate of the center of the circle, is 12. Now, these are the coordinates of the center. That is actually our main target. That is the main thing that we need to know. Now, the value of the radius, you can see that the radius r is equal to the square root of 400. That means it is going to be equal 20. So this is 20. So these coordinates are given in the meters. Then it means this radius is 20 meters. This is the value of the radius. Now we know also the coordinates of the center. So coordinates of the center are negative 16, and y coordinate is 12. And here from this picture, you can see that all information is actually appearing, which we really need to know to find the gradient and then the equations of these tangents of this circle. So here you see these are the coordinates of the y point. We have the coordinates of O prime A, O prime B. Now, if we find the gradient of the line O prime A and the line O prime B, we can find the gradients of these tangents and then the equations. So it means our next task is to find the gradients. So first, let's calculate the gradient of the line O prime A. The gradient of O prime A. So the equation of the gradient is the following. That is, we have m of the radial vector towards A is equal to the delta y divided by the delta x. So what delta y is, we can see that the y coordinate of the point A, it is 18.840 negative 12 divided by delta x. What delta x is, that the x coordinate of the point A, which is negative 34.794 minus 16. So minus minus will be positive. So if we actually solve it, we can find the answer is 6.840 divided by minus 18.794. So the gradient of radial vector that we got here, MRA is equal to 0 point, and that will be negative, of course, 3639. Okay, now from this gradient, we can calculate the gradient of tangent AC. Our tangent AC, the gradient will be that we can call it MTA. That will be equal to negative inverse of negative reciprocal, that is the right word, for of this MRA, which is negative 0.3639. Now, this negative will be cancelled with the negative, and now we will get this answer, which is 2.7476, because we need to go down to a millimeter. So we should have at least four decimal points. So we have here four decimal points. So now we have the gradient, and we also have coordinates of the point A. Using these two, we can actually use the general equation of the straight line, and we can find the equation of tangent at a point A. So then equation will be that y minus y1. What y1 is? The y coordinate of point A, which is equal to 18.840. This is equal to the gradient, which we just calculated, 2.7476 times x minus. Now, the x coordinate of our point A, which is negative, so that negative will make this negative positive. We got 34.794. Okay, so now you can simplify this equation in the following way, that y is equal to 2.7476 will multiply with x. So we get 2.7476x, and 2.7476 times 34.794. And then you can see on this left side, we have this negative 18.840 that moves to the right side, and it will also be positive number. And then you actually need to add it in the product of 2.7476 with 34.794, and answer will be positive 114.441. So this is our equation, and we can call it that this is equation A, because this is actually belongs to the tangent A. Now we need to find the equation of the tangent, which is actually at the point B, or you can call it BC. So this tangent is crossing the tangent AC at a point C, and we actually looking forward to calculate the coordinates of C. Now the method will be the same, meaning that first we will calculate the gradient of the line O prime B, because we have these coordinates of both of these points. Then negative reciprocal of this gradient will be gradient of our tangent BC. So then we can actually use the same method that we adopted over here, and then we will get the equation of the tangent BC. So this is equation of BC. So equation is the following that you will get by following the same method, that y is equal to negative 0.4663 x, then positive 26.6064. I'm going up to four decimal places. So now we can call that this equation is the equation B. This both of these equations, we know that these are the equations of the tangents. And these tangents, they are intersecting each other at the point C. So it means that if we solve these both equations simultaneously, we can find the coordinates of x and y. How we can do this? That from this equation A, you can see that it is written as a y is equal to this, and the equation B is written as a y is equal to this right hand side. So it means that if left hand sides are the same, then of course right hand sides are also same. So now what we can do here, we can put them equal to each other. So now we can say that solving equation A and B, A and B simultaneously. So how we can do this as the following, that 2.7476x plus 114.4421, that is equal to negative 0.4663x plus 26.6064. Okay, now we can see that this is the x coordinate. This is actually also the x term. So, and on the other hand, this one and this one are the constant terms. So you can actually bring this negative x term to the left side and add in the x term on the left hand side. And the constant term from the left hand side, you can move it to the right hand side. And then you can actually solve this equation to find the value. And what would it be? So let's move this negative x term from right side to the left side, and you will get that the 3.2139, and this is times x will be equal to, we move this constant term to the right side, so it will be negative there, and we have a positive 26.6064. So our answer is negative 87.8356. Now, this is our x coordinate. We have a constant times x. So our x coordinate will be that this constant moves to the right hand side and it will divide. So we will have a negative 87.8356 divided by 3.2139. And this answer is equal to, it must be negative and negative 27.3295. So this x is in the units of meter. So if you want to write it in millimeters, then answer will be negative 2732. We can even make it 30. 30. So these many millimeters, because we want to give the precision down to millimeters. So now if we have now this x coordinate value, we can calculate the value of y coordinate. How can we do that? So this is very simple. What you need to do, you need to take this value of x and use any of these two equations A and B and substitute that value in any of these equations and solve it for the value of y. For example, we use the equation A, and according from the equation A, so you can say that from equation A, what we would have that if we put this value, that y is equal to, we have 2.7476 times negative 27.3295, and we have a positive term there, which is so plus 114.4421. Now we can solve this equation for the value of y, and that is equal to 39.3499. So if you want to write it in millimeters, because this answer is in the meters, so our answer in millimeters is 39350. So this is the answer in millimeters. So we can say that now our final conclusion is that coordinates coordinates of point C, which is the common point of these two tangents, are the following. These are, we calculated one is negative, and I am giving the answer in millimeters. 27330, and the other one is 39350. So these are the coordinates of this point of intersection of these two tangents. So this is actually the method of solving this question. So once again, so we can very quickly go through that what is the procedure or the method of solving this question. Always try to understand the question, that what the problem is. The problem is that we have two tangents of a circle, and the equation of the circle is given, and these two tangents, they are crossing each other at a point C, and we need to find the coordinates of that point C. So this means that this point C is a simultaneous point for both of these tangents. So it means if we know equations of both of these tangents, we can solve them simultaneously and we can find the coordinates of C. So for this, what we need to know one point at the tangent, which is given A and the B. The second, the gradient. What we do not know the gradient, what we know about the circles, that the rules of the circles are the following, that this radial vector is always at 90 degree, meaning it is perpendicular to the tangent. So then if we can find the coordinates of the center of this circle, then we can find the gradient of this radial vector. That will be the negative reciprocal for the tangent of the AC. Similarly, you can find actually the gradient for the tangent BC. Now, if you have the gradient, if you have the coordinates of one point on the line, you can find the equation of the straight line. Once you have these two straight lines, that will be a very simple first order equations. You can find the equations of the tangents, solve them simultaneously, and find the coordinates of their point of intersection. I hope you understand the solution. If you do not understand, leave your comments, so we will try to reply to your all comments. And here I once again show that you need to show your all working. But remember that here I am only calculating the gradient of the tangent AC, but you should also do the calculations for the tangent BC and then do the full procedure or the workout to find the equation for the tangent BC. Thank you very much.